Alright, this video is for the Review Algebra Skills Worksheet. Numbers 1 and 2 ask you to graph using a table. I'll give you a hint, but I'm not going to do this one for you completely because we put this on this to kind of lead you into what we're going to look at the rest of the week. So when you make a table, make sure you pick some x's, -3, -2, -1, 0, 1, 2, and 3. And then plug them into the absolute value of x plus 3. These are your y values. Plug them into the function, and then draw the graph. So that's all I'm going to give you for those first two problems, because we really want you to work through that one on your own. Now, number 3 says to solve for b1, and it's a equals 1/2 h b1 plus b2. Hopefully you recognize this as the equation for the area of a trapezoid from geometry. So in order to get b1 by itself, I need to get rid of the 1/2, the h, and then the b2. In order to do that, I'm going to multiply by 2 first. The 2 times 1/2 is 1. So I get 2a equals h times b1 plus b2. Now I need to divide the h. H divided by h is 1. Divided by h. We get 2a over h equals b1 plus b2. Now I can subtract my b2 from both sides, and I get 2a over h minus b2 equals b1. Okay, number 4 is x plus 1 over 3 is greater than x minus 4 over 2. So I'm going to multiply both sides of the equation by 3, and I get x plus 1 is greater than 3x minus 12 over 2. And then if you want, you can get rid of the 2 as well by multiplying both sides by 2. Eventually, okay, we get 2x plus 2. Don't forget to distribute. Is greater than 3x minus 12. Subtract your 2x. And 2 is greater than x minus 12. Add 12. And 14 is greater than x. I always flip it. X is less than 14. And then I draw my number line. 14, open circle, shaded less than. So remember that this says this answer is saying that all the x values are less than the 14, because 14 is greater than x, so we can rewrite it. X is less than 14. All right, we're looking at number 5. Let's see. Number 5 is 4 minus the absolute value of h plus 2 equals -5. Now, be careful when you write your absolute values, because I've seen a couple people write an absolute value in a 2 in one step, and then in the next step they treat it as a 12. You actually get confused by your own writing, so be careful on something like that. In this one, we'll make sure we need to isolate my absolute value first. So the absolute value has to be by itself before I can write two equations. I'm going to subtract 4 from both sides. I get the negative absolute value of h plus 2 equals -9. Then I'm going to divide by the -1, or the negative, and I get the absolute value of h plus 2 equals +9. So don't be too quick to see a negative on the other side and say, oh, it has to be no solution. You can't make that determination until you're at this step where the absolute value is by itself. Now I can say what's inside the absolute value can equal +9. and the statement will be true, and what's inside the absolute value can equal a negative 9, equals negative 9, and then solve both equations. Subtract 2 from both sides. So h is equal to 7 and negative 11. The equations don't need to go on a number line. The inequalities do. So number 6 is the absolute value of 3k plus 7 minus 1 is greater than 2. And I'm just going to draw a little line there to help divide our work up. Again, isolate my variable, so add 1 to both sides. I get the absolute value of 3k plus 7 is greater than 3. Greater than, we want everything inside the absolute value to be more than 3 away from 0. So remember, we looked at this number line, and if I want to be more than 3 away from 0, I'm actually looking at the values that are greater than 3 or the values that are less than 3. These are the ones that have a distance from 0 that is more than 3. And so we can write our equations. 3k plus 7 is less than negative 3, or 3k plus 7 is greater than positive 3, and we can solve those two equations. Let's see, subtract 7 and subtract 7 over here. I'm going to move over to this line. So I get 3k is less than negative 10 divided by 3. K is less than negative 10 thirds. Or do not leave out the or. We get 3k is greater than negative 4 divided by 3. So k is greater than negative 4 thirds. Draw that on a number line because it's an inequality. We didn't have any signs flipped, so it shouldn't be weird at all. It's not, we don't have greater than a negative or less than. At this point in the equation, we should have asked ourselves, is it greater than a negative? No. Okay, we're good. It's going to have just two solutions. And negative 4 thirds, open circles, greater than 4 thirds, open circle, less than negative 10 thirds. All right, so number 7 is compound inequality n over 2 minus 6 less than or equal to 3 and 1/3 n plus 1 greater than or equal to negative 2. So we'll solve the first one, add 6 to both sides. We get n over 2 is less than or equal to 9. Multiply both sides by 2 because this is n divided by 2. Multiply by 2. N is less than or equal to 18. And so we bring the and down. Take this one, subtract 1. 1/3 n greater than or equal to negative 3. Multiply both sides by 3. And we get n is greater than or equal to negative 9. So we have an and statement where n is less than 18 and n is greater than or equal to negative 9. So when we draw this on a number line, we'll draw 1 in red, the 18 in red, less than, and has to be true for both statements. The negative 9, also greater than or equal to, greater than the negative 9. So when you're doing this, we want to make it clear which part of the solution we're looking at. This is our overlap, and is both, so that's what we're interested in. And most of the time you're going to see the equation written, the answer, negative 9, less than or equal to n, less than or equal to 18, with this between statement. Let's see, divide that up. Number 8. Number 8. is 2/3 y minus 4 equals y over 5 minus 4. So I have two fractions here. I have a denominator of 3 and a denominator of 5, so the LCD for 3 and 5 is 15. So I'm going to multiply every part of this equation, even the ones without fractions, by 15 to get rid of my denominators. So when I do that, 3 goes into 15 5 times, and 5 times 2 is 10y. And 4 times 15 is minus 60. It's kind of a messy 60. Let's write that again. And then 5 goes into 15 3 times. 3 times y is equals 3y minus 60. So I'm going to subtract my 3y and add my 60, and I get that y, 7y, is equal to 0, and therefore y is equal to 0, because 0 divided by anything is 0. So that's my answer. Let's see, number 9, the absolute value of k minus 2 over 7 equals 0. Now when the absolute value of equation equals 0, we don't write two equations because there is no positive and negative. We want them to be 0 away from 0, and there's only one exact answer that will give us that. So k minus 2 over 7 is equal to 0. We'll times by 7 to get rid of my denominator. K minus 2 equals 0. Anything times 0 is 0. And add 2 to both sides. And we get k equals 2. So y equals 0 on number 8. K equals 2 on number 9. Number 10. The absolute value of 2y minus 9 is less than or equal to 27. Now less than is we want all the numbers. Remember, we're looking inside this absolute value. We want everything possible in here to be less than 27 or equal to 27 units away from 0. So less than the 27 is going to be, or less than 27 away from 0 is going to be these numbers. The numbers that are less than 27, those are all less than 27 away from 0, and all the numbers that are greater than 27 away from 0. Now again, this is our between statement, and we really want to focus on practicing writing those between statements, because mathematically it's the more proper way, and it's the way it's going to be written on almost all tests and quizzes. So we put our negative 27 on the left, the less than or equal to symbol, 2y minus 9, less than or equal to positive 27. We add 9 to both sides, and we get negative 18, less than or equal to 2y, less than or equal to 36. Divide by 2. Whatever I do to the middle, I do to the right, I do to the left, and I get negative 9, less than or equal to y, less than or equal to 18. So we get negative 9, positive 18, greater than or equal to, greater than or equal to. Now remember, this is the final answer. This top number line is what 2y minus 9 can equal, anything in this range, and then when we get our final answer, that is what the y actually can be. Anything between negative 9 and 18 will make this original equation true. Number 11, negative 1 less than 3 times d minus 2 less than 9. So we have another between statement here. We're going to distribute in the middle, so negative 1 less than 3d minus 6 less than 9. I'm going to add 6 to the middle to eliminate that. Add 6 and add 6. I get 5 is less than 3d less than 15. Divide by 3, and we get that 5/3 is less than d, which is less than 5. And that is going to look like this. That's your final answer. Number 12. Solve for b. This is the variable we're interested. A equals 3b plus c divided by 4. So my goal is to get b by itself. We're going to start by multiplying by 4 to get rid of our denominator. We have 4a equals 3b plus c minus c from both sides. 4a minus c. A and c are not like terms, so you can't combine them. Equals 3b and divide by 3. So b equals 4a minus c divided by 3. Number 13, 4 equals negative 2 times the absolute value of k minus 3. Now again, absolute value equations, you have to get the absolute value isolated before you can make any determinations about no solution, before you can write your two equations. So the first thing we need to do is divide by a negative 2. I have negative 2 equals the absolute value of k minus 3. At this point, can absolute value ever equal a negative? The answer is no. So my answer is no solution. And we would really like you to write because absolute value cannot equal a negative. We really want on these quick short ones a little explanation as to why you believe it's no solution, to prove that you really do know what you're talking about. A 14, absolute value of 6x minus 5 is greater than 0. We'll add 5, and the absolute value of 6x is greater than 5. Are we greater than a negative? Are we less than a negative? No, so this isn't one of our special cases, so we'll write our equation. Remember, greater than, we're looking at greater than 5 away from 0, and less than negative 5 are the numbers that are more than 5 away from 0. So we're going to write those two equations, 6x, or inequalities, greater than 5, or 6x less than negative 5. And we'll divide both sides by 6. We get x is less than negative 5/6, or x is greater than 5/6. On a number line, we have 5/6, negative 5/6. Open circles, greater than positive 5/6, less than negative 5/6. Number 15, absolute value of h plus 7 less than 0. Question here, when is the absolute value less than 0? Never, right? Everything we put in here is going to come out positive. If I put in negative 10, the absolute value of negative 3 is positive 3, which is not less than 0. Put in negative 100, absolute value of negative 100 plus 7 less than 0. That's negative 93 absolute value, which comes out as positive 93. So this answer here is no solution, because the absolute value always comes out positive, or is always positive, and that's never, which is never less than 0. Number 16. Negative 6 times the quantity of 2x minus 3 plus 2 equals negative 8x plus 20 minus 4x. So the first thing we're going to do is distribute my negative 6 to both the 2x and the negative 3. So we get negative 12x plus 18 plus 2 equals, combine our like terms, they're on the same side of the equal sign, so we're going to do negative 8 minus 4 is negative 12x plus 20. So negative 12x plus 20 equals negative 12x plus 20. At this point, I noticed that the equations are exactly the same. You may not see that right away and add 12x to both sides, and you get 20 equals 20. When you get the variables disappear and you have a true statement, your answer is all real numbers. And your set notation for that is x such that x is contained in the set of all real numbers, like that. Okay, number 17. The absolute value of x plus 7 equals 3x minus 5. So the absolute value equal to an equation. That means in the end we're going to have to check for extraneous solutions. I need to write my two equations. X plus 7 can equal 3x minus 5, and x plus 7 can equal negative 3x minus 5. Red. So this is the most important step. That's why I put it in red. You have to apply the negative to the whole right side of the equation. So let's get our variables on the one side, minus 3x. So I get, oops, that's a minus. Negative 2x plus 7 equals negative 5. Minus 7, negative 2x equals negative 12. So x equals 6. And this we're going to distribute. Negative 3x plus 5 equals x plus 7. So I'm going to add 3x. So I have 4x plus 7 equals 5. Minus 7. 4x equals negative 2. And we divide by 4. We get x equals negative 1/2. So right now I'm at x equals 6 and negative 1/2. So let's see what happens when I plug them in. We're interested in if this will be negative. So we have 3 times 6 is 18. 18 minus 5 is a positive 13. So that works because 6 plus 7 is 13. So this side came out positive, so that one works. If I plug in negative 1/2, I get negative 3/2 minus 5, a negative are negative. When I'm adding, or when I'm subtracting a negative minus a negative, it becomes more negative. So that's going to be extraneous because it cannot be equal to the negative. So our only answer is that x equals 6. Alright, and number 18, the last on this set of problems. Negative 3 plus 3/4 m greater than or equal to 5. We're going to add 3 to both sides. 3/4 m is greater than or equal to 8. Multiply by 4/3. And m is greater than or equal to 32/3, and put that on a number line. 32 over 3, closed circle, greater than. Okay, number 19, evaluate the expression 3 minus 2 bracket 4 divided by 2 times 3 plus 1 bracket plus 6. So your brackets and parentheses are similar, so I'm going to do what's inside the bracket first. Multiplication and division come from left to right, and this notation makes it look very confusing because you see 2 times 3 with the parentheses and you want to do that first, but we don't. We're going to divide 4 divided by 2 and then multiply by 3 because multiplication and division go left to right. So let's write down the rest of the problem. 4 divided by 2 is 2, so this is what I'm going to do in red. 4 divided by 2, so I get 2 times 3 plus 1 plus 6. Now I'm going to do the 2 times 3. 3 minus 2, bracket 6 plus 1 plus 6. And then inside the bracket, I can finish that out. 3 minus 2 times 7 plus 6. At this point, I just change it to parentheses. Now my multiplication is going to come first, so I end up with 3 minus 14 plus 6. And addition and subtraction happen left to right as well, so we're going to do 3 minus 14, which is negative 11, plus 6, and lastly, negative 5. Okay. And then number 20, we're going to add that up here. We have evaluate the expression when a equals negative 2, b equals 1/3, and d equals 3/4. And it's a plus b squared divided by d. So a is negative 2, so I'm going to put negative 2 in place of the a, plus b, which is 1/3 squared divided by d, which is 3/4. So when we have a large fraction bar, we have to do the numerator before we can do the division. So exponents are going to come first. 1/3 squared is 1/3 times 1/3, negative 2 plus 1/9 divided by 3/4. And negative 2 plus 1/9, we can get a common denominator of 9. Put the 2 over a 1 times by 9 over 9, and we get negative 18 over 9 plus 1 over 9 is going to give us negative 17/9 divided by 3/4. And then this part confuses a lot of us. When we have a fraction over a fraction, it just means really negative 17/9 divided by 3/4. And to divide fractions, we multiply by the reciprocal times 4 over 3. And there's no cross canceling there. So our denominator is 27. And our numerator is negative 68. So our final answer is negative 68 over 27. Okay, now the last section of the worksheet. Name the sets to which each number belongs using real, R, Q, rational, I, irrational, Z, integer, W, whole, and N, natural number. And just as a quick review, your natural numbers are your counting numbers, 1, 2, 3, 4, and so on. Whole numbers are 0 and your counting numbers. Integers are whole numbers and their opposites, so you have negatives and positives and 0. Rational are numbers that can be written as a fraction, so a repeating decimal and a terminating decimal, as well as fractions. And then real would be numbers that don't qualify as rational. They are irrational and real. We have not yet come across those imaginary numbers, but we will get there. So negative 6, numbers where that include negatives are integers, so this is Z, and it's also rational, and it's also real. Number 22, we have a pattern, so we're repeating decimal 4, 5, 4, 5, 4, 5. That means it's rational. It could be written as a fraction. So that's rational Q and real. 0 is whole, integer, rational, and real. -4/7 is a fraction, rational and real. And the square root of 3 can't be written as a fraction. It's a decimal that goes on without a pattern, so it's irrational and real. And you can go to Mrs. Whoop's website for some flashcards on practice on that, and she also has a link to a video to watch. All right, that's all I have for you guys. Hope this helps.